7.3. 7.3 is complex fractions. And I think just the name makes you think, oh my word, what in the world we got going with complex fractions? Complex fractions look like things like 6x over 5y squared all over 8x squared over 10y cubed. Ugly looking things, aren't they? But what makes them look kind of ugly is that you got a fraction in the numerator and you got a fraction in the denominator. And what does the bar line mean when we look at fractions? What does this mean? It means division, right? So what that means to take care of this problem is I'm going to have 6x over 5y squared divided by 8x squared over 10y cubed. Doesn't look so bad when you look at it that way, does it? But because it's division, what has to happen? Yep, 6x over 5y squared. Flip the second one, or the value after that piece. And then you go through and you cancel different things. So what can we say cancels in here? So if I look at 6 and 8, I can put a 2 into 6 and I can put a 2 into 8. We okay so far?
2.
Okay.
2 on the 6, not 3. 2.
No, I put a 2 into 6. 2 into 6 went 3 and 2 into 8 went 4. Okay, so no, we don't want a 2 up there. And then if I look at x's, I've got an x here and I have an x squared down there. So what should I put next to my 4 when I reduce it?
1x.
Just a single x. And then the other piece, I need to cancel my 5 and cancel my 10. And then I need to look at my y squared and my y cubed, and this part cancels and this part just simply becomes y. So now I need to go through and figure out what's in the top. 3 times 2 is 6 and a y is left over. And in the bottom, 1 and 1 don't make a difference, and I've got a 4 and an x. So my answer just simply comes out to be 6y over 4x. Okay or not okay?
Wouldn't there be a y there? Oh, I see, it was on the top left.
Yep, the y's on the top. Whoops. Y's up here on the top, but it's not on the bottom, and so therefore it stays in the top. So that's one variety of complex fractions. The other variety is where you have 1 over x plus 3 minus 1 over x all over 1 plus 3 over x. That's got a whole bunch of pieces to it. But if you look at it, the top piece that's on here looks like we just got done doing in 7.2 because it happens to be a subtraction problem. And if I look at the bottom, it's a addition problem. And so basically what I have in method number 1 that I can use to solve this is to go through and work with each piece separately. So if I work with just the top piece, since we just finished that section, what do I have for my common denominator? Okay, so x plus 3. Remember, we need everybody from the first, and we need what we don't have in the second, so I need an x for my common denominator. Okay? Okay. Then, what does my 1 in the very top of the first one get multiplied by? Gets multiplied by x. Okay. And what does the negative 1 get multiplied by? Whoops. Plus 3. Okay. Yay or nay? You okay? Okay. So now I need to just finish what my top is. 1 times x is x. Negative 1, because it's a subtraction, negative 1 times x is a negative x. Negative 1 times a positive 3 is a negative 3. And that all happens to be over x plus 3 times x. So what's my numerator? X's cancel. Leaves me with negative 3 all over x plus 3 times x. You okay? What was that? Okay, are we all right with that one? Okay, then I go down to the bottom one and I got to do the exact same thing down here. So what's going to be my common denominator? Well, this 1 is over 1, so my common denominator is going to be good old x, right? You okay with that part? Okay. So what does 1 get multiplied by? It's got a 1, but I need an x, so it gets multiplied by an x. Plus 3, and what does 3 get multiplied by? A 1. So my new numerator in this case is going to be x plus 3 all over x. Okay, so now what do I got left? Well, once I get this solved and I get this solved, I am down to this part. So what has to happen to finish it? So the big bar line in there means to divide. So that means I have a negative 3 over x plus 3 times x times, remember what do we do with this piece? Flip it. And so what's my final answer going to be? Well, does anything cancel? The x's cancel, correct? And so what am I left with? Negative 3 over x plus 3 times x plus 3. And that's my answer. Okay, this is method 1. Method 1 is kind of tedious. And it's long because in method 1 you've got to do all of this work of working with each fraction separately. Okay? But there is an easier method. We're going to do the same problem using the easier method, and then you can choose which one you like. Again, we had to solve each separate problem and come up with its answer. But in method 2, what makes it different is we're going to find the LCD of all denominators in the complex fraction. And we're going to do a few of these, so don't think we're going to leave you with just these two. So if I find the common denominator of everything, whoops, I'm going to rewrite my problem. Yep, I can move it up a little bit. Okay, so if I move it up, what's going to be my LCD of this whole problem? So in the top, we found our LCD was x plus 3 times x, correct? That's from up here when we found our LCD. We okay with that part? Do I need anything different for my LCD for my denominator? Because the x is already here, correct? So I don't need another x. So this is the common denominator for this whole thing. So now what I'm going to do is multiply the LCD by each piece in the problem to remove all denominators. So when I take this whole fraction and multiply every piece by this LCD, what happens is this gets multiplied by this whole thing. The x plus 3's cancel, so all I'm left with is an x. You okay so far? What would I be left with in this other one? X and times this. The only thing I'm left with there is a x plus 3. Okay or not okay? All over. What do I have to multiply 1 by in the bottom? One's over 1, so I need this whole thing, right? So 1's going to get multiplied by x plus 3 times x. Okay or not okay? Again, what you're doing is you're canceling if you can cancel anything. If I multiply the 3, what's it going to get multiplied by? Well, the thing that cancels here is only the x, okay? So it's going to get multiplied by an x plus 3. So this becomes my values that I work with. So what comes out of it? Well, I got x. Negative 1 times x is a negative x. Negative 1 times 3 is negative 3. And what comes out of this bottom part? What will I end up with? Well, when I multiply 1 times x, I get, or this piece has to be FOILed, so 1 times this is going to be what it is. So x times x is x squared. 3 times x is 3x. Go to the second, 3 times x is 3x, and 3 times 3 is 9. We okay so far? Okay. And what's my final answer? X minus x is gone, so I have a negative 3. And x squared, 3x and 3x is 6x plus 9. And you're looking at this and saying, that answer doesn't match that answer. Does it? Yeah, it does, because if I factored the bottom, it would come out as x and x, and it would come out as a plus 3 and a plus 3. So these two do end up matching each other. All right? I don't know. For me, if I'm looking at this, both ways have their advantages. This way you're at least seeing what you got for your pieces of coming out. I think this one, method 1, takes me longer than what method 2
Put
does.
it in that way, or will they make you do x plus 3 squared?
Oh, no, Hawks let you put it in this way. Yeah, Hawks let you put that in there. Yeah, they have no problem. Either of these are correct in Hawks, so it doesn't look at these two being separate. They're the exact same thing. So no, that doesn't change. Okay? So as far as this goes, that ends up matching. All right? Questions? Anything else with this one? Okay, let's do another one. Okay? Because I think if we do a few more, and you'll get a better idea of what happens with those, so you can see what does end up taking place with them. So let's try this one. 1 over x plus 3 over 2x all over 1 over x minus 1 plus x over 1. So if I did that one, I could end up going through and working with each separate problem. Okay, I find my common denominator here, and then I do the bottom one and work it all out and come up with my answer. But I think we'll take another look at method 2, because you're probably really going to find it's going to save you time doing method 2 as opposed to what you do with method 1. So remember, we're finding the LCD of the whole problem. So my LCD on the top, what do I have in my first one? Well, I got an x, right? What do I still need in the second one to make it match? I need a 2. If I go down to my bottom, what would I still need? Okay. If I go to the last one, do I still need anything in this last one? I got a 1, so that's not going to make any difference in anything that I have. So this becomes my LCD. You okay in finding that? Yes? Okay. So now what I want to do is I want to take this whole thing and I want to multiply it by my LCD of 2x times x minus 1. Okay, so what does my first thing get multiplied by? The only piece of it that I have is the x, so 1 is going to get multiplied by a 2, correct? And what else? Yep. What will the 3 get multiplied by? Now again, it removed the denominators. It got rid of this piece of my top value. And what's going to happen to the bottom? What does 1 get multiplied in this case? 2x. And what does x get multiplied by? It's multiplied by a what? Just an x minus 1? It's got to actually get multiplied by a 2x, correct? Because it's got a 1 here. I need the whole thing. Okay or not okay? I see head shaking yes, so we must be doing something in the right manner. Okay, now all I got to do is do my distribution. 1 times 2 is 2. 2 times x is 2x. 2 times the negative 1 is a negative 2. So far so good? Okay. Distribute the 3. 3 times x is 3x. 3 times the negative 1 is a negative 3. And then what? So now in the bottom, I get 2x. X times 2x is 2x squared. But I still need to take 2x squared and times it by each piece inside those parentheses. So 2x squared times x is going to give me a plus 2x cubed. We okay? And 2x squared times a negative 1 is a negative 2x squared. Yes or no? I honestly think that these are a little bit better doing it this way because I don't have all of those separate fractional building things to do, but you guys might not think so. But combining 2x plus 3x is 5x, negative 2 and a negative 3. The bottom, I had to rearrange this so I get it all in order. So I can put a 2x cubed minus a 2x squared plus 2x. Now I got some factoring to do, because if you look at this, what can I factor out of the top part? A 5 gives me x minus 1. That's the only thing that if you go back and work with each one of these separately, you don't usually have a lot of factoring to do at the end, but these you still got factoring. What can I pull out of this part? A 2 and an x. And what does that leave me with? X squared minus x plus 1. And did all of that help me out at all when I factored it? Does anything cancel? Can I factor this more? Can't factor it more, can't cancel anything. So really it didn't help me. Okay, but I don't know until I try it, until I take a look at it and see if I can factor it out. So either of these answers you could put into Hawks. Okay, they're both the correct answer. Okay.
That's it.
Yeah.
That's as far as you go.
Yeah. Yep. That's as far as you end up going with that one. And so, yep, that would end up being your answer to that. Okay or not okay? All right, let's do another one. So I want to make sure we get enough practice in, and so you have a few with your notes that you can go home and take a look at. So how about this one? 6 over x squared minus 4. Now do realize that not every problem that you have that comes up in Hawks is going to have, of course, this many pieces. I've been trying to pick out the ones that have the most stuff in them so that we work out some of the tougher ones, and so you have those for examples to work through. So what's my LCD going to be? What was it? Nope. Well, yeah, it will be this whole thing, but this needs to be, if you take that x squared minus 4 and factor it, it factors to x minus 2 and x plus 2, right? Okay. So I need all of it, right? Remember, we always need the first thing. Okay. Do I need anybody else to get my second one? I've already got a x plus 2 in there. You okay with that part? Okay. already got an x plus 2, so I don't need anything else there. But what about my bottom? Do I need an x minus 2? Well, I got an x minus 2, so I don't need that one. And this x squared minus 4 is what I just factored, so do I need any of those? No. Okay. So then what I can do with this whole thing is I can take it and multiply the whole thing by x minus 2 and x plus 2. So what comes out of this? So x squared minus 4 matches this perfectly. So does 6 get multiplied by anything? No. Minus 1, does that get multiplied by anything? Okay. Then go to my bottom. Does 3 get multiplied by anything? Does 7 get multiplied by anything? Good old 1. This 6 is also being multiplied by 1 as well. So just to let you know that it is there. So this one worked out pretty good. I mean, I don't have a whole lot to do up there. 1 times 6 is 6. Negative 1 times x is a negative x. Negative 1 times a negative 2. And in the bottom, 3 times x is 3x. 3 times 2 is 6. Plus 7. Combine like things, 6 and 2 is 8 minus x. And what's in the bottom? 3x. 6 plus 7 is 13. Can I do anything with that? Does it factor? It doesn't. So, I gotta quit wondering. Because it doesn't factor, that's my answer that I put in there. Okay or not okay? Okay, good. All right. The last piece in this section that they give you is they look at complex fractions. Not complex fractions, but complex algebraic expressions. And what those involve is order of operations, because they put together complex algebraic expressions. And they look at things like x plus 2 over x minus 2 divided by x squared over x minus 2 minus x minus 2 over x squared. It's order of operations because what do you notice about it? What do you notice? Within the order of operations, what do we notice? Well, we got order of operations because I've got a division and I've got a subtraction. So what does order of operations tell me I need to do first? Multiplication and division. So I got to do this piece first. So that leaves me with x plus 2 over x minus 2 times x minus 2 over x squared. So what comes out of all that? And then I got minus x minus 2 over x squared. So x minus 2's cancel, correct? Okay. So what does that leave me with? Is x plus 2 over x squared. That's all that's left with my division that I changed to multiplication. Minus x minus 2 over x squared. So now I'm kind of back in 7.2 where I needed to have common denominators. Do I have common denominators? Yes or no? Yeah. So all I need to do is take care of the subtraction. And that subtraction means the first stays the same. But this means I need to take that whole piece and multiply by negative 1. Negative 1 times x is a negative x. Negative 1 times a negative 2 is a positive 2. And so what is my final answer? Well, x minus x, gone. Positive 2 and a positive 2, 4 all over x squared. And normally in every one of these, you do end up with usually a common denominator comes out of them when you do your multiplication or you do your division, whichever you happen to need to do with those. So it's just kind of sticking together some common things that you happen to have within those. Let me see if I can find another one, a really complex one. This one. Let me flip my page. You okay? Can I flip it? Okay. 1 over x plus 6 minus 2 over 3x divided by x plus 6 over 12x. So another complex fraction, meaning, or combined fractions. So meaning that with this one, I need to do what first? Division, yep. So 1 over x plus 6 stays, minus 2 over 3x, but this part has to invert, so I get 12x over x plus 6, and so what cancels in there? 3x and 12x gives me a 4, and a 1. So really all I have left is 2 times 4 is 8 over x plus 6. Then bring my first part down, and it's nice of them because they gave me a common denominator already, so that's wonderful. 1 minus 8, what's that leave me with? Negative 7 all over x plus 6. Yeah, all over x plus 6. So that would be my value that I would have with that one. So, do we need to do some more?
Yeah, that was an easy one. You pulled that one out of your head. That one was not that very difficult.
That was actually in a Certify in Hawks. Yeah, that was in a Certify. Because when I go through and do these, of course I write down all the things that run across stuff when I do the certifications and things. So no, that one was in there. One other one that they slip in is this type. 3 over x to the negative second plus 4y to the negative second all over 3x to the negative third minus 5y squared, or to the negative second. I guess we'll put a negative second on that one too. Now what makes this different than anything we've had just so far today? Negative exponents, yeah. What does that mean whenever you get a negative exponent? They need to travel, right? They all move. They don't stay in the top, they go to the bottom. So this really is a complex fraction when you take a look at it and put 3 over x squared plus 4 over y squared all over 3 over x cubed, get rid of my negative, minus 5 over y squared, and it becomes a complex fraction. You see how that happened? These move to the denominators. Both of these pieces move down to the bottom part, and so therefore it became a complex fraction. So now I need my LCD like we've been doing before. We might as well finish it. So I need an x squared, correct? I need a y squared. But then when I get to this x cubed, do I have a cube? I have a squared, so what do I still need? I still need an x. Perfect. Yep, I still need an x. I've got a y squared, so I don't need a y squared. So really, what is my LCD? My LCD is x cubed y squared. Okay? So, if I take this whole thing and multiply it by x cubed y squared, what does 3 get multiplied by? Just an x? Perfect. What does 4? Oh, and a y squared, thank you. Yep, can't forget my y squared. He gets even if you don't put him in there, okay? Because it catches up with you if you don't have it. So then, what does 4 get multiplied by? X cubed. And then on the bottom, what will I have? I need a 3y squared. Yep. And what does 5 get multiplied by? And then if I go back and I look at that whole thing, is it going to help if I factor anything out of it? What do you think? I could pull out an x squared in the top, but that's not going to help me because I can't do anything in the bottom, so that's my final answer. Okay? So I can't do anything else with it. So beware if they give you these negatives, because I know you're going to sit at home and you're going to look at this and you're going to say, what in the world were those negative things? And they pop up. Okay? So be real careful in making sure you get that stuff in place. All right, anything else that you guys can think of that we need to stick up here at this moment? You're all good? Okay, so I will